Hello students, so in this video and in the next couple of videos we're going to do some examples from section 2.5 on measures of position. So a measure of position allows us to determine how a data value compares to the other data values in the same data set. So we will discuss the following measures of position in this section. So we're going to discuss quartiles, percentiles, and z-scores. Okay, so quartiles, percentiles, and z-scores are all examples of measures of position. So the book opens up section 2.5 by discussing what quartiles are. Okay, and quartiles are an example of fractiles. Okay, so fractiles are numbers that partition or divide an ordered data set into equal parts. Okay, so eventually we'll talk about what quartiles are, again, which are fractiles, and then we'll also talk about what percentiles are, okay, which is also another fractile. So let's go to the first question in the homework. Okay, so it says a student's score on an actuarial exam is in the 78th percentile. Right, and then it says, what can you conclude about the student's exam score? And then it gives you these answer choices. Okay, so before we can answer the question, we need to understand what a percentile is. Okay, and that comes a little later in the section. So percentiles are discussed on page 106. Okay, and the title here is Percentiles and Other Fractiles. Okay, so essentially a percentile divides a data set into 100 equal parts. Okay, so the number of percentiles is going to be 99, right? So from the first percentile all the way to the 99th percentile. Okay, so you need 99 percentiles to divide the data set into 100 equal parts. If we look at the example here, right, it'll tell us how we can interpret the percentile that's given in the homework for problem 1. Okay, so example 5 says this graph here called an ogive represents the cumulative frequency distribution for SAT scores of college-bound students in a recent year. Okay, and the question is asking what score represents the 80th percentile. So I'm not going to have you read graphs like this and determine, for example, the test score for a particular percentile, like this example asks. Okay, but in any case, right? From the graph, we can see that the score at the 80th percentile, okay, is approximately 1250. Okay, that's not a great way to determine the score that corresponds to the 80th percentile, because that can be very imprecise, okay, depending on how you read the graph there. Okay, but in any case, the solution is that from this graph here, you can see that the 80th percentile corresponds to a score of about 1250. Okay, so what's the interpretation of that? Okay, that's the important part. Okay, so what this means is that approximately 80% of the students had an SAT score of 1250 or less. Okay, so just really quickly, let's summarize what a percentile is. So percentiles are used to divide an ordered data set into 100 equal pieces. The percentile of a data value tells you the percent of data values in the data set that are less than or equal to that value. Okay, so for example, a data value that is at the 75th percentile means that 75% of the data values are less than or equal to. Okay. So the question. Select the answer choice that most appropriately describes what a percentile is. Okay. So basically, if a student scores at the 70th percentile, it means that 70% of the students scored lower than that student. Okay, or the student, likewise, the student scored higher than 78% of the other test takers. Okay, so it looks like answer choice D would be the best answer choice. Okay, and you can read this for more information. Okay, and then question 2 is very similar, so I'm going to go ahead and skip it. Okay, so The next topic has to do with quartiles, and then using what's called the interquartile range to identify outliers in a data set. So we'll talk about that next. Okay, so before we can answer this question, we have to discuss what quartiles are. Okay, so the quartiles of a data set divided into 4 equal pieces. So therefore, there are 3 quartiles. Okay, so just like the percentiles divided data set into 100 equal pieces, right? And we just learned that there are 99 quartiles. Okay, likewise, there are 99 percentiles. I apologize, 99 percentiles. Right, there are going to be 3 quartiles which divide an ordered data set into 4 equal pieces. So you've got the first quartile, Q1, the second quartile, Q2. Okay, the second quartile is also known as the median, okay, which we discussed in section 2.3. Okay, and then we have the third quartile, Q3. All right, and then we have what's called the interquartile range of a data set, which is abbreviated as IQR. Okay, and the IQR is equal to Q3 minus Q1. Okay, so go ahead and read the definition of the quartiles given on page 102. Right, and example 1 tells you how to find the 3 quartiles of a data set by hand. Okay, so I'm going to go ahead and skip that. Okay, so we will eventually use Stackwork to help us find the quartiles of a data set. Okay, so this is what example 2 discusses. So I'm going to go ahead and skip example 2. Okay. All right, so now we have what's called the interquartile range. So it says a measure of variation that is based on position. Okay, it's called the interquartile range. So the interquartile range tells you the spread of the middle half of the data, okay, as shown in the definition. Okay, so it's a measure of variation, okay, that gives the range of the middle portion of the data. Okay, so the IQR is the difference between the third quartile and the first quartile. All right, and we're going to use this to identify the outliers in a data set. Okay, so remember, an outlier is a data value that's far removed from the other data values in the data set. Okay, so either the data value is extremely small compared to the rest of the data, or it's extremely large when compared to the rest of the data. Okay, so how do we use the interquartile range to identify outliers? Okay, right, so you first find the quartiles, right, Q1 and Q3. Okay, and then you use the quartiles Q1, Q3 to compute the interquartile range. So the IQR, or interquartile range, is equal to Q3 minus Q1. Okay, and then you multiply the value of the IQR by 1.5. Okay, so in step 4, we subtract 1.5 times the IQR from the first quartile. Okay, we're going to call that the lower fence. Okay, so any data value that's less than this value, okay, is an outlier. Okay, likewise, we add 1.5 times the IQR to Q3 to get what's called the upper fence. Okay, so any data value greater than Q3 plus 1.5 times the IQR is also an outlier. Okay, so based on information, the interquartile range of a data set can be used to identify outliers because the data values that are so again, you got to fill in the boxes. Okay, so data values that are less than. Okay, you got to look at your answer choices carefully. So these are the only answer choices in the second box. Okay, likewise, these are the answer choices in the last box. Okay, so remember, okay, said in the book that any data values greater than Q3 plus 1.5 times the IQR, okay, there's going to be an outlier. Okay, so we got to change this to greater than. Okay, so greater than Q3 plus 1.5 IQR, or less than Q1 minus 1.5 times the IQR. So that's also what it said in the book. Okay, so any data value that's less than this is also an outlier. Okay, and that's how we can complete question number 3. Okay, so in the next question, we're going to use this data set to complete the following actions. So in part A, we're going to find the quartiles of this data set. In part B, we're going to find the interquartile range. And then part C, we're going to identify any outliers in our data set. Okay, so we're gonna do this in Stackwork. So we're gonna use Stackwork to help us get the three quartiles, Q1, Q2, Q3. Okay, so let's go ahead and copy the data in Stackwork. Okay, paste the data in an empty column. Okay, and what we want to do is go to the stat menu. Okay, select summary stats and columns. Okay, select the column that contains the data. Okay, and what we need are the quartiles. Okay, so Q1 and Q3 are the first and third quartiles respectively, but what's the second quartile? Okay, remember, okay, the second quartile is also known as the median. Okay, that's important to know. Okay, so if we want the second quartile, we're also going to select median. Okay, making sure to hold down the control button if we're selecting multiple summary statistics. So let's go ahead and click compute. Okay, so for the data stored in the column var2, okay, the first quartile is 35, the third quartile is 45.5, and then the median is 40. Okay, that's the second quartile. So Q1 is equal to 35. The second quartile, or the median, is equal to 40. All right, and lastly, the third quartile is equal to 45.5. All right, let's go ahead and check our answers. Okay, so now we're going to find the interquartile range. Okay, so remember the interquartile range is equal to Q3 minus Q1, so we can do that on a handheld calculator. Okay, so Q3 is 45.5, and we're going to subtract from that Q1, which is 35. Okay, and we get 10.5 as our IQR. All right, then we're going to identify any outliers in this data set. Okay, so we discussed how to determine whether a data value is an outlier. Okay, so like we talked about earlier, the IQR can be used to help us identify outliers. Okay, right, so we start by finding the quartiles Q1 and Q3, and then we calculate the interquartile range, which we just did, so Q3 minus Q1. All right, so let's go ahead and calculate the lower and upper fences for our data set. Okay, so knowing that the IQR is 10.5, okay, right, we're going to do Q1, which is 35, and then subtract from that 1.5 times the IQR of 10.5. Okay, that's what I'm calling the lower fence. Okay, the book doesn't use that terminology. Okay, so the lower fence for determining whether a data value is an outlier for this data set is 19.25. Okay, so let's just write that off to the side somewhere. Okay, so our lower fence is, so the lower fence is 19.25. Okay, next we're going to get the upper fence. Okay, by taking Q3 and then adding to it 1.5 times the IQR. Okay, so Q3 was 45.5. Okay, so we're going to do plus 1.5 times 10.5. Okay, and that'll give us the upper fence, which is 62.5 or 61.25. So the upper fence is 62.25. Okay, so any data values that are greater than 62.25 or any data values that are less than 19.25 are going to be outliers. Okay, so the fences, right? The lower fence and upper fence are like your cutoffs, right? The cutoffs for data values that are going to be outliers. Okay, so what we want to do is sort the data first. We can see the only outlier is the number 15. And let's check our answer.